Hi students, in this video too we are going to discuss some important name reactions, okay, from the chapter your aldehyde, ketones and carboxylic acid. So first we'll start with Rosenmund reduction. So Rosenmund reduction, so in this reaction, so acyl chloride, okay, RCOCl or acid chloride, okay, it is converted to the corresponding aldehyde with same alkyl, same number of carbon atom. So your aldehyde group is your CHO. So what is converting here? COCl will get converted to CHO. How? By hydrogenation. So by hydrogenation means reaction with hydrogen in presence of catalyst, palladium as catalyst, okay, uh, and over, okay, so your barium sulfate, so barium sulfate or sulfur simply. So when you do this reaction, okay, hydrogenation using palladium as catalyst and BaSO4 as poison, then your acid halide or acyl halide will get converted to corresponding aldehyde. Simply in this reaction, COCl will get converted to CHO. For example, if we have CH3 COCl, if we do the hydrogenation using palladium as catalyst, so see, your reagent is very important, and barium sulfate as poison, okay, what happen is like you will get here only COCl group will convert to CHO, okay, rest will remain as it is, just a CH3 basa, COCl will get converted to CH3CHO. Similarly, if we have, okay, this one, then what happen if you do the hydrogenation reaction, okay, again using palladium, this is palladium as catalyst, barium sulfate as poison, again what will happen is your COCl will get converted to CHO group. So that means you will get is a benzaldehyde. So whatever alkyl group is present, so only the change take place in COCl2 to your CHO group. Suppose we have CH3, CH2, CH, CHO, okay, C double bond A, sorry, C H3 here, CH3 here, then Cl. Again, if we do the hydrogenation, Rosenmund reduction. So Rosenmund reduction means hydrogenation using palladium catalyst, barium sulfate, then acyl halide or acid halide will get converted to aldehyde. How? Only the COCl group will get converted to CHO. So this is the reaction which is taking place. Okay, now in this reaction or from this reaction, from Rosenmund reduction, your formaldehyde, okay, it's not prepare, is not prepare. Why? Because, so see, in order to prepare your CHO, right, HCHO formaldehyde, what you need is this thing, right, as C double bonded O Cl, isn't it? And this is not stable, okay, stable at room temperature. So for this reason, okay, so Rosenmund reduction, from Rosenmund reduction one cannot prepare formaldehyde. Now here what is the role of barium sulfate is, it is like controlling the reduction. Okay, so तिम्रो यता के गर्दैछ भन्दाखेरि, now when you reduce COCl, it will get converted to CHO. BaSO4, if it is not there, okay, so uncontrolled reduction hunदै जान्छ. That means from aldehyde again you will get alcohol. So this BaSO4, okay, so this is acting here as a poison which is reducing, right, the activity of palladium, so which you have already done in surface chemistry. So poison ले के गर्छ भन्दाखेरि activity of catalyst लाई घटाइदिन्छ, or with the help of this we are what is happening here is like controlled reduction is taking place. So Rosenmund again acid halide, okay, and your hydrogenation, palladium catalyst, barium sulfate, your poison, and the product is corresponding aldehyde. Now next is Stephan reaction. Now what is this reaction? Nitriles. So nitriles means your CN, right? Alkyl group attached to CN. So this is your nitrile. Are reduced to corresponding imine. Okay, imine is your R, then CH, double bonded NH. So we call these as imine. IMINE. Okay, so this is converted to corresponding with same alkyl group, corresponding imine. Okay, kasari with stannous chloride. Okay, SnCl2 and presence of hydrochloric acid, that is HCl. So it gives is a imine, and this upon hydrolysis, okay, this upon hydrolysis के हुन्छ भन्दाखेरि will give corresponding aldehyde with same number of, with same alkyl group and CHO. Okay, यहाँ के हुँदैछ भन्दाखेरि overall reaction is like your CN is getting converted to CHO, corresponding aldehyde. Your cyanide or nitrile is converted to corresponding aldehyde. So again, यहाँ के हुन्छ? So first your nitrile, okay, so this one will get converted to imine, corresponding imine. How? When it reacts with SnCl2 and HCl, then this upon imine upon hydrolysis give corresponding aldehyde. So as a whole, how can we write this reaction is, so your nitrile bio, okay, so first ma we'll treat it with stannous chloride, hydrochloric acid, and followed by, if we do the hydrolysis, okay, directly we'll get is CHO. Teti bela we can skip one step. Okay, sir. So this is preparation again of aldehyde. So let us take an example. Suppose we have CH3, CH2, okay, then CN. So there will be a triple bond in CN, right? Okay, this nitrile, so if we react it with stannous chloride HCl, so first ma the conversion take place from nitrile to imine. So के हुन्छ खाली यहाँ मात्रै change हुन्छ. So CN will become now CH double bond. I will just each will get one hydrogen. Okay, CH double bond and NH. So CH3, CH2 यहाँ केही change हुँदैन. CN triple bond थियो. You one molecule add हुँदैछ. So one bond break हुन्छ. Triple bond मा एउटा bond break भयो भने double bond हुन्छ, and each will have one hydrogen. So this is imine. Okay, this upon hydrolysis, so के हुन्छ भन्दाखेरि, like simply, though this not happen, यता oxygen पाउँछ. Okay, we'll get is CH3, CH2, CHO as a product. So your CN here is getting converted CHO at the end. How? Reacting it with stannous chloride HCl followed by hydrolysis. त्यसरी नै if we do CH3, CH2, CH2 and CN, again triple bond छ, stannous chloride HCl, what will happen? The same will get converted, like corresponding imine will get, हैन, यो सम्म same बस्छ, benzene ring same, then CH2 group same, then CH2 group same. Now C and triple bonds, one molecule of hydrogen goera add huncha and we'll get is imine CH double bonded and H, right? And this upon hydrolysis के हुन्छ भन्दाखेरि, okay, nothing will change. यहाँ केही change हुँदैन, खाली यहाँ CHO हुन्छ. This group will change to CHO. So we'll get is benzene ring, no change here, but CHO. Okay, this group imine will get converted to CHO. So we'll do one more. So CH3, CH, CH3, CH2, CN. Okay, if we do like first ma reacting it with stannous chloride, hydrochloric acid, followed by hydrolysis. Now what is the product? Yes, yeah, directly it will get converted to, like, no need to write one steps, we can skip one step. So we'll get directly CH2 here, C, and will get converted to CHO. Okay, this is your Stephan reaction. So Stephan reaction ma reagent is stannous chloride, hydrochloric acid followed by hydrolysis. Right? So pauncha ke imine and at the end aldehyde as a product. Now next is ETARD reaction, very simple one. Okay, so chromyl chloride is your CrO2Cl2. So your chromyl chloride, okay, it oxidizes methyl group of toluene. Now toluene, what is it? Vandakiri benzene ring with methyl group. So benzene CH3 is toluene. Okay, now when you react the two, so your junche chromyl chloride oxidizing agent to, now it oxidizes this methyl group to chromium complex. So chromium complex ma ke huncha bandakiri, okay, two hydrogen niskincha. So तीनटामा दुईटा हाइड्रोजन गयो, सो एउटा मात्र रह्यो एन्ड भयो इन प्लेस अफ द्याट यो क्रोमाइल क्लोराइड गएर कम्प्लेक्स फर्म गर्छ कसरी अक्सिजनसँग थ्रु अक्सिजन इट विल फर्म बन्ड विथ दिस मिथाइल ग्रुप ओ भयो एउटा देन सिआर ओके एन्ड यहाँ जुन चाहिँ ओ छ ओके द्याट विल ह्याभ वान हाइड्रोजन जुन यहाँबाट निस्केको छ देन Cl2 अगेन ओ सिआर OH Cl2. So this is what called chromium, okay, complex. ठीक है सर, chromium complex मा H2 को place मा हुन्छ OCr OH Cl2 दुईटा. Okay, now this लाई if we do the hydrolysis, okay, acid hydrolysis गर्दा के हुन्छ, again you whole thing, okay, only this complex one you जुन चाहिँ छ that will get converted to CHO. So we'll get is benzene ring and CHO. Right, so this is what called ETARD reaction. So again a toluene react garcha, okay, kosanga chromyl chloride, and we'll get is like a chromium complex, and this chromium complex upon hydrolysis give benzyl dehyde as a product. Okay, sir, very simple one. Next is GATTERMANN-KOCH reaction. GATTERMANN reaction cha, GATTERMANN-KOCH reaction cha, duita are different. Okay, so these are from two scientists. Now your reaction ma ke huncha, benzene or its derivative. So first we will take simple molecule, that is benzene. Okay, is treated with carbon monoxide and hydrogen chloride. So carbon monoxide सँग treat गर्छ, then hydrogen chloride सँग treat गर्छ, okay, in presence of anhydrous aluminum chloride. So anhydrous यहाँ पनि use गरेको छ र अझै use गरेको छ Friedel Craft मा. So anhydrous aluminum chloride or cuprous chloride, okay, Cu2Cl2. Then के हुन्छ भन्दाखेरि this benzene or substituted benzene यहाँ के हुन्छ simply your CHO group will add, okay, and you will get is benzyl dehyde or substituted benzyl dehyde. Again benzene ring or any substitute or its derivative ela को सँग treat गर्नु पर्यो GATTERMANN-KOCH मा. Yes, reagent is important, carbon monoxide, hydrochloric acid in presence of aluminum chloride and hydrous, okay, or cuprous chloride. So these two act as a catalyst, okay. Final product is benzyl dehyde. The reaction is called GATTERMANN-KOCH reaction. Suppose we have like Cl. Now if we have this one, so since again this GATTERMANN-KOCH reaction is like electrophilic substitution reactions, okay, so now this is ortho para directing group. So most probable product are like your isomers of ortho and para, okay. Cu2 Cl2, either of two you can write one. So one product CHO and another one, okay, para isomer. So these are the product when we do the GATTERMANN-KOCH reaction for chlorobenzene. So next is Clemmensen reduction. So here what we are doing is just 4 reactions, preparations of aldehydes, right? Now from here, so this is what called reactions of aldehyde. Now Clemmensen reduction, okay. Now here the carbonyl group of aldehyde and ketone is reduced to CH2 group on treatment with zinc amalgam concentrated HCl. So your carbonyl carbon, okay, of your aldehyde or ketone. So this will now change to which group? CH2. CO will change to CH2, okay, when on reaction with zinc amalgam, okay, and concentrated hydrochloric acid. So when we react the two, CO, okay, will change to CH2. For example, if we have benzene ring, CH2, then CHO, okay. If we are doing this Clemmensen reduction, that is reaction with zinc amalgam and hydrochloric acid, okay, what happen is CO group will change to CH2. Now here you need to know which one is your CO, right? So aldehyde, whenever you write down aldehyde, how you are going to write? Kasari lekcha aldehyde, like your benzene ring, okay, then CH2, then C double bonded O and H, okay. So this is your aldehyde. So ke huncha your Clemmensen ma your CO group will get converted to CH2, right? So duita hydrogen and one hydrogen gardakheri, what would be the product? Your CH2, this CH2, then CO. यहाँको जुन चाहिँ C and O यो केमा convert भएको छ CH2. दुईटा hydrogen plus one hydrogen गर्दा now we'll have 3 hydrogen. So this is the product during Clemmensen reduction. So again, if we have CH3, C double bonded O, okay, CH2, CH3 plus zinc amalgam and concentrated HCl, what is the product? Again here, okay, this group will now convert to CO will convert to CH2, CH2, CH3. By CO kema convert was CH2, your CH2 as it is, no change, and this again no change. Suppose we have cyclohexanone, okay, so this is a group, right, which will reduce. So zinc, amalgam and concentrated HCl. So again this is Clemmensen reduction. So Clemmensen reduction ma ke huncha timro CO group will get converted to CH2. So you will get is cyclohexane. And hydrogen no dekhaunda ni huncha. So you will get is cyclohexane. Again last one. Okay, so if we have this one COCH3, if we do this Clemmensen reduction, zinc, amalgam, concentrated hydrochloric acid, what will happen? CO group will get converted to CH2. So simply you will get is, so CO group identify kara, then you can easily write down the product. So CO will get converted to CH2 or jasto cha teste barsa, there will be no change at all. This is what the Clemmensen reduction is. Now last one is your Wolff-Kishner reduction. Okay, again this is same thing, like conversion of your carbonyl carbon to aldehyde. Carbonyl carbon of aldehyde or ketone to your CH2 group. Okay, but here we'll use this different reagent. So यहाँ हामीले के गर्छ भन्दा we'll treat this with hydrazine. Now what is hydrazine भन्दाखेरि NH2 and NH2. So यसलाई भन्छ hydrazine. Okay, हाइड्रोजन सँग रियाक्ट गर्दा के हुन्छ भन्दाखेरि नाउ हाइड्रोजन को दुईटा H, okay, and carbonyl को O, this one will remove as water, okay, and the two will form a bond and will get is like C double bond O र H2 गयो, then N, then NH2. So this is your hydrogen, okay. यसलाई हाइड्रोजन भन्छ, carbonyl carbon, okay, of aldehyde ketone सँग react गर्दा it will form hydrogen, and this upon hydrolysis यसले के गर्छ, this bond, अब though the mechanism is different but simple मा हामीले what we can write is like यसले के पाउँछ O and this one will get is OH. So you will get is, okay, sorry, okay, so sorry. so hydrolysis कसरी गर्दैछ भन्दाखेरि, okay, it is heating with potassium hydroxide, okay, or sodium hydroxide in high boiling ethylene glycol. So ethylene glycol sanga heat karta. So at the end you will get is like this whole group. Okay, hydrogen will now, this group will convert it to CHO, CH2, and nitrogen gas will release. Okay, again your carbonyl carbon, when it reacts with hydrogen, okay, के form गर्छ hydrazone. So hydrazone ma your C double bonded N and NH2. This upon heating with potassium hydroxide in high boiling your solvent ethylene glycol, okay, so this will now change to CH2. So this is your Wolff-Kishner reduction. यहाँ पनि same हो, this is the target of the reaction is same, like from carbonyl carbon to CH2, but here we use is different reagent, that is hydrogen followed by heating with potassium hydroxide ethylene glycol. भयो? So for example, cyclohexanone. Again, so if we react it with hydrogen, we'll get is hydrogen. कसरी यहाँबाट water निस्किन्छ and carbon र nitrogen को bond form हुन्छ N, then NH2. Now this upon reaction with heating with potassium hydroxide, okay, ethylene glycol. So के हुन्छ? So this whole change again at the end H आउँछ, no need to write H, you will get is cyclohexane. Okay, so again suppose you have CH3 CO CH2 CH3. so if you are reacting it with hydrogen, okay, first, then followed by heating with potassium hydroxide in high boiling ethylene glycol, then the product is your CO group will change to CH2. So aru sabai same basa, CH3 ne basa, CH2 there will be no change, but CO group will convert to CH2. So sorry, so this is your Wolff-Kishner reduction, though your both are same, Clemmensen and this one, but in this case we use is different reagent. Again, okay, COCH3. What will happen if you react it with hydrogen? Okay, then heating it with potassium hydroxide in high boiling solvent ethylene glycol. What will happen? Your group, only this group will change to CH2. So we'll get is CH2, then rest CH3. ठीक है सर, CO के मा convert भयो CH2 मा. Last एउटा गरौँ example. Okay, CH3 CO CH3. Suppose यसलाई first react गर्दैछ NH2 NH2 hydrazine. Okay, what will happen? This one and this one, okay, form hydrazine. Now hydrazine, now what is it? CH3 C double bonded with nitrogen, then NH2. Okay sir, here is your CH3 हैन. Now your group and last finally के गर्नु पर्यो? KOH, then heat, then ethylene glycol ma, and the product, this one will now change to CH2. We'll get is CH3 CH2 CH3 as a product. From propanone we'll get is propane. So this is Wolff-Kishner reduction. Thank you all.